extra practice, I'm just going to kind of split it into, the 4 different parts, and there's going to be 4 different videos. So this is for part 1. So what's going on is you have something called a critical value, which is actually just the z-score of how accurate you want to be, and that's how accurate you want your confidence interval to be, okay? So the first thing we need to do, and after you do this a couple times, it kind of makes sense, but essentially what happens is we have our normal curve, right, our means in the middle, and depending on how accurate we want to have, that's how much space is in between, right? And so if I want a 95% accuracy here, that means I have left over 5% on the left and the right, so it would be 2.5% and 2.5%, right? But if I want to switch that, and I want to be super accurate, and I want to get a 98% accuracy, then that means there's 2% left over for both sides, which makes a 1% and a 1% on each side. What you're trying to do is you're trying to find what this z-score is. That one right there, we're trying to find out what that z-score is, okay? And I don't really care about this area over here other than the fact that you have to know that they need to be equal. Okay, so for a 95% confidence interval, I draw it, I got 95% here, so then that means there's 2.5% on each side. So what we do now is we go to the second step, which is calculate the z-score, which is used by your inverse norm. So it's going to be the inverse norm of 0.02501, because we're calculating the z-score based on our standard normal curve that has a mean of 0 and a standard deviation of 1. This second step was just kind of a hint that I gave kids that kind of helped them remember. It's 1 minus whatever your confidence interval is, and you divide by 2 because you're dividing it by 2. Okay, so when I type this in the calculator, second distribution, and because I have the percent, I need to do the inverse norm. Oh, hold on. Okay, so let's try that again. Second distribution, inverse norm, 0.025, and then 0 and 1. And so my z-score, it says negative 1.96. I really don't want a negative. It's just the positive that. It doesn't matter what side of the graph it's on or what side of the normal curve it's on. So your z, your confidence interval for that one is 1.96. You can't see that, okay? So what I'd like you to do now is for 2, 3, and 4, try and draw your picture like I did up here, figure out what's on the left and the right, and then do your inverse norm, and then come back and look at the video. I'm not going to explain it again. I'm just going to miraculously put the answers up there for you to check, and hopefully that will help. If you're still stuck on it, maybe go back or come in and ask me. But I think after watching one step on what you would do, you'll be okay. All right. So come back when you're done so you can check your answers. Okay, so here's your next one. Take a look at it, see if you have any questions, and when you're done with this, go on to the next video for part 2, which is calculating margin of error.